Hello, so I'm just going to do a quick review of the end of unit homework, end of unit 15. I'm going to talk a little bit about rounding, and then I'm going to talk about surface area, which is a big one for people. And then at the end, because it was a brain question, I'm going to talk about compound shapes. So these are the questions most people struggled on. Rounding was just throughout, so I'll just talk about that quickly, and you'll see it when I do the surface area and the compound shapes. So with rounding, you should not round your answer until the very end, because if you round halfway, it changes what result you'll get at the very end. So if you do pi times 3, and you get, you'll get 9 point something, 3 times pi, you get 9.42424, blah, blah, blah. And then it says, and then you want to times that by 3. If you've rounded this to 9, and then you times by 3, you get 27. But if you round your actual answer, so 9.424, just use the calculator and put it in, times 3, you get 28.27, blah, blah, blah. So you see, even there, really quickly, we've rounded here, and it's given us a different answer to what the actual answer should be. So you won't lose all the marks, but you will lose some marks if you round halfway through the question. So when you're using a calculator, just take whatever it's given you in the calculator and just stick it straight back in the next question. Okay, and then you should only round once at the very end. Okay, so that's just a quick recap on rounding. A few people were making that mistake, so I thought I'd mention it. But the main thing is surface area. So I'm going to go through a few different examples. When we're talking about surface area, we're talking about the area all the way around the shape. So we have the area of these different faces. And there's some on the back as well. So if we talk about perimeter, we talk about the distance all the way around the outside of the shape. With a 3D shape, we're sort of talking about the distance all the way around the outside, but it comes out as an area because we have flat surfaces. So the way we do this, I saw some people using like a formula, which is fine, but you've got to think about what you're doing. So if we're doing this shape here, we can unfold it so that it has a net. So if we bring this front down and the back down, one of the nets would be, we'd have like this, and then like this, and then this would be like this. So it's just me sketching a net out quite quickly. So if you're good at nets, it'll help you with the surface area. So this is one of the nets. We have our 2 and our 3 and our 8. And all these ones along here are 8. And then this is 2 and 3, because it matches up with here 2 and 3. And so once you've got the net, it's actually much easier to work out. So 2 times 3, the area of this bit is 6, 2 times 3. The area of this bit is 2 times 8, 16. This one's 3 times 8, which is 24, and 16, 24, and 6. And then we would just add them up. So with a rectangular prism, I saw some people going 2 times 3 is 6, 3 times 8 is 24, and 2 times 8 is 16. So we want 2 lots of 6, add 2 lots of 24, add 2 lots of 16. So I add 2 lots of 16, that should be an add sign, sorry. So I saw a lot of people doing this, which is fine, because this will give us the right answer, but you've just got to realise what you are doing when you're doing this. So if we work that out, we get 92. So we're doing 2 lots of 6 because we've got 2 faces that have 6. 2 lots of 24 because we've got 2 faces. Oops. We've got 2 faces that are 24. And 2 lots of 16 because we've got 2 lots of 16. So it works for the rectangular prism, but when we move on to something like this triangular prism, we've got to think a bit harder about what faces we're working out. So again, I'm going to do the net. So I always fold sort of each edge out, each end face, sorry, out. Oops, a bit rubbish. Like that. And then we'd have the small back bit, which we can't see, it would be like this back bit here. And then we have a big long front bit that folds over the top, this top one. So now if we put our measurements in, this is 3, this is 4, this is 3, this is 4, this is 5, 5, which means that if you imagine this folding on, then that means that this one here is 5 as well, and this one's 6, 6, and 3, 6. You should be able to fill in the rest now. So, like I said, if you get better at nets, it makes it much easier. So this is just unfolding the shape and finding out how long each edge is. Also, sometimes they might not give you all the measurements. You see here, this is a 3, this is a 4, it's a right angle triangle. So you should be able to work out this using Pythagoras. But we're not doing that at the moment, we're doing surface area. So now the next step is just to work out all the areas. So 6 and 3 is 18. 6 and 4 is 24. 5 and 6 is 30. Now, for a triangle, we do base times height times a half. Half base times height. So we have 3 and we have 4. So you imagine this is the height and this is the base. Or the other way around, it doesn't matter. So we have 3 times 4 times a half. A lot of people are forgetting to do this half, but because it's a triangle, we need to remember. So we get 6. So this is 6 and this is 6. And then we just add them all up. So 6, add 6, add 18, add 24, add 30. And you notice this is much different from the rectangular prism, because we're not timesing anything by 2. I mean, we could times this one by 2, because it's the front and the back. But all the rest are all individual faces. So we have the 6s, we have the 18, which is this back one. We have the 24, which is the base. Oh, we've done blue already. It's the base. And then the top one is the 30, again on its own. So you've got to work out which ones you're doing and why you're adding them up. So 6 and 6 is 12, add 18 is 30, add 30 is 60, add 24 is 84. So hopefully you followed along with that one. In the end of unit, again, I had lots of people not doing this half, and lots of people just doing the same thing as for the rectangular prism. But you're going to think it's a little bit different. Okay? And then the last surface area one was question 10, this cylinder. So again, let's think of the net. So if we have our circles are going to be on either end of the net, and then if you imagine this is the middle bit here, and if you unfold it, you unroll it, it comes out into a rectangle like this. Imagine if you fold it along these lines, it would curl round all the way around the circle and become a cylinder. So if you have something cylindrical, like a can or something, if you imagine you cut down and unfold it, this is what it would look like. And then we can put our measurements in. So we have 12. This is 8, because this is this height. But we need to know more. We need to know what this length is. And we need to know the area of the circle. So yeah, we need this length so we can work out the area of this rectangle. So what is this length? Well, this bit I'm drawing is this bit, because it's this edge of the rectangle. So it's this edge of the circle. So it's the circumference of the circle. So we need to have the area of the circle, the circumference of the circle, and then we can find this. So let's do the circumference first. So circumference, oops, I do C equals pi d, or equals 2 pi r. I like this one because we've got the radius. So we're going to do 2 times pi times 12, which equals, let me just do it, 24 pi, 75.398 dot dot dot. I'm putting dot 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 because I'm not going to write the whole number out, but I'm also not going to round it. So I'm just going to use that number that I've got and put it straight into this next calculation. So this area here of this bit, so A equals 8 times what I've got on my calculator. So I'm just going to times the answer I've got on my calculator by 8, and I get 603.185. Dot, dot, dot. And then we need to do the area of the circle. So this is going to be pi r squared. So we get pi times 12 squared, and we put that in our calculator. Pi times 12 squared, 452.389. And then we have to add these two together. So this is 600. Oh no, I've missed one bit as well. 603.19. So I've rounded there, but I haven't. I know that I put this dot 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 to say that there's more numbers afterwards. I'm just rounding because it's more accurate. So anyway, we've got, I know to use the whole number, which is this one here, or the one in the calculator, and this one, which is here, 452 and 452. So then I can do 2 times this, add 603. And our answer, let me just work it out. So I'm going to times it by 2, the answer I've got on my calculator, and add, and I'm just going to put 8 times, I'm just going to do the calculation again, so I get the exact number. So I get 1,507.96, and that's rounded now, centimeters squared. Or is it? Sorry, it should be millimeters squared. Okay, so that's how we do it with the cylinder. I hope that made sense. So we unfold it, we get the area of the two circles, and then to get this area of the rectangle, we have to find the circumference. Okay, so last thing, compound shapes. Most people were fine with the area, it was the perimeter again. So I'm going to do a simple compound shape, really simple. Let's do a square with side length 6 and a rectangle like this with 8 and 2. So if we wanted to find the perimeter here, some people would do 6 add 6, add 6, add 6, add 6, add 2, add 8, add 8, add 2. But that wouldn't be quite right because we want the area all the way around the outside, which is this way, like this. But you see we're missing this middle bit. So we need to figure out which edges we're going to use. So we're going to use this edge, this one, this one, this one, this one, this one, and we need to find out this edge, which is just 8 take away 6, so this is 2. And they're the ones we're going to use, because they're the ones on the outside. So these two bits here we ignore. So we just add it up, 6 add 6 add 6 is 18, add 2 is 20, add 2, add 8 is 30, add 2. So this perimeter of that would be 32 centimetres. So now let's look at the more complex one that was in the book. Which edges are we going to use? Well, we're going to use this one's on the outside, this one's on the outside, this one, and this half a circle. So we don't have, some people added 2 times the radius for the semicircle, but we don't need that bit. And some people did 2 times 12, but we don't need that because it's not on the outside. So let's work out the circumference of the circle. So we can do circumference equals pi d. or 2 pi r, whichever one you like. Pi d here for me because we've got the diameter. So 12 pi is the circumference of the full circle. So 12 pi equals 37.699. That's that would be if it was the full circle. So imagine the full circle. So for the semicircle, it's half a circle, so we just need half of that. So we do circumference of semicircle equals, well, I'm not going to do this one. I'm just going to do 12 pi divided by 2, 6 pi. So you can just put the answer in, or you can just do it in terms of pi and then get your answer, which is 18.8490. Okay, so again, we're not rounding to the very end, and then we're going to have 8 add 12 add 8 add our 6 pi, and this is going to give us the exact answer. So let's just do that. 28 add 6 pi, we get 46.84, and then it's 9, so we're going to write it to 86.85 centimeters. Okay, and just to check the question, it said give your answer correct to 1 decimal place. So there you go, I've gone wrong. It should be 46.9 centimeters because this was a 4, remember? So this was 4.9. So there we go. Hopefully that's made sense, cleared it up a bit. If you still have questions, if you're not understanding this, you need to message me. Hopefully there's no more problems there. The rest of the end of unit was done quite really well, just a few small mistakes. But yeah. Right, I'll see you later.